In this video, I'm going to show you how to find the value of y prime using implicit differentiation, whose equation contains a trigonometric expression. Just a quick reminder that whenever we get the value of y prime, that is equal to the value of dy over dx, or f prime of x. Find the value of y prime in the given equation. So the given equation is sine of angle x plus y is equal to y squared cosine of angle x. In order for us to find the value of y prime, first, we need to get the derivative of sine of angle x plus y, and as well as the derivative of y squared cosine of angle x. To get the derivative of sine of angle x plus y, we need to use chain rule of differentiation. To do that, we need to get the derivative of sine. So the derivative of sine is cosine, and the angle is still x plus y. After we get the derivative of sine, we need to get the derivative of x plus y. So the derivative of x is 1, and the derivative of y is 1. Whenever we get the derivative of the given algebraic expression with a given variable y, do not forget to put y prime. And that is equal to the derivative of y squared cosine of angle x. As you can see, the right side of the equation has two factors. We have y squared and cosine of angle x. So we need to use product rule. In order for us to use product rule, we need to get the derivative of the first factor. So the first factor of y squared cosine of angle x is y squared. So we need to get the derivative of its first factor, multiply to its second factor, which is cosine of angle x, plus the derivative of cosine of angle x, multiply to its first factor, which is y squared. So the derivative of the first factor, which is y squared, is 2y. And there is a y prime. Multiply to its second factor, which is cosine of angle x, plus the derivative of the second factor. So the derivative of cosine of angle x, which is the second factor, is negative sine of angle x. Multiply to its first factor, which is y squared. The next step is we need to simplify the left side of the equation. To do that, we need to distribute cosine of angle x plus y to the expression 1 plus 1y prime. So we need to multiply cosine of angle x plus y to 1. We have cosine of angle x plus y multiplied by 1 plus cosine of angle x plus y multiplied to 1y prime or y prime. We will have cosine of angle x plus y, y prime. And that is equal to, still we will have 2y, y prime, cosine of angle x. Since the sign of angle x is negative, and it is plus, positive times negative, still we will have negative y squared sine of angle x. So plus negative sine of angle x, y squared is the same as negative y squared sine of angle x. Now, the next step is we need to transfer 2y, y prime cosine of angle x to the left side of the equation since it is in the right. By doing that, the sign will become negative. And then, y prime cosine of angle x plus y will remain in the left side of the equation. And that is equal to, we need to transfer cosine of angle x plus y to the right side of the equation. Since it is from the left, it will become negative. And then y squared sine of angle x will remain on the right side of the equation. So we have minus y squared sine of angle x. Since we are looking for the value of y prime, I transferred all the terms with y prime to the left side of the equation. We have y prime cosine of angle x plus y minus 2y y prime cosine of angle x, that is equal to negative cosine of angle x plus y minus y squared sine of angle x. The next step, we need to factor out y prime. By doing that, we have y prime multiplied to cosine of angle x plus y minus 2y cosine of angle x. And that is equal to negative cosine of angle x plus y minus y squared sine of angle x. Since we need to solve for the value of y prime, we need to divide both sides of the equation by cosine of angle x plus y minus 2y cosine of angle x. The next step, we need to cancel cosine of angle x plus y minus 2y cosine of angle x. Therefore, the value of y prime is equal to negative cosine of angle x plus y minus y squared sine of angle x over cosine of angle x plus y minus 2y cosine of angle x. I hope you gain a better understanding on how to find the value of y prime or the derivative of y using implicit differentiation.